All right, we're going to finish 13.1, and we had gotten to the point where we had looked at a couple different information about interest, and we had looked at an effective yield, which was a way of comparing different sort of interest rates with different ways of compounding. And the last thing that we did last time was we did this formula right here, which was A equals PE to the RT, or A PERT, and it was for continuously compounded interest. Now, continuously compounded interest is what is typically sort of viewed when you look at the stock market. They'll tell you the continuous interest rate over that particular year. That's how they'll look at that. It's also going to be used in our next problem, which is why I'm going back and mentioning it now. All right, so we're going to take a look at inflation. Have you heard of inflation before? You should have. It's one of those things that comes up in the news every time somebody runs for anything on a different political party or whatever, right? All about, there's always this issue of inflation. So let's talk a little bit about what inflation is. Inflation is an increase, so the increase, we should say in the, not I, the increase in the cost of living over time. CPI is the Consumer Price Index, and what it does is it takes products, common products that people buy, and it looks at what happens to the increase of the cost of those products over time. So they're real common things, right? So we're not talking about, Grey Poupon. Not everybody buys it. We're talking about bread and milk and ground beef and chicken and the things that people typically go, green beans, tomatoes, right? Lettuce, I don't know. The things that people typically go to the store and buy. So what the Consumer Price Index does is it has a large number of items that are purchased by large numbers of people, typical grocery items. And it looks at what the price of those items are as a whole and compares that to the price of those items, 10 years ago or 15 years ago or 5 years ago. And it looks at how those prices have increased over time. Okay? So they don't use one specific item. They don't specifically say the cost of milk. Okay? They look at a whole bunch of items and they talk about the increase in that over time. Okay, that makes sense? Okay. So what we're going to do is we're going to look at the increase in a particular item using a consumer price index increase, okay, using an inflation number that would have been given to this, okay? Has everybody pretty much written everything down? Are we good to go? All right. So, for example, in 2010, a small car cost $18,500. Okay, so we're looking at sort of an average price of your standard small car. You go to purchase a small car, a new price, $18,500. We're going to find the inflation price, what the car would cost, not the same car, but an equitable car. That is, a small car, an average small car, what it would cost if you were buying it in 2020. Is everybody with me? We're not talking about the exact same car. Obviously, that car went down in value. We're talking about an equitable new car, small car, average things, whatever. The standard run-of-the-mill stuff on it. Okay? By comparison, same kind of item. All right, so how do we do this? Well, we're going to use that same formula that we used for continuously compounded interest, which looks like this. Now, let's remember what these things are. So I don't mean actual values. I mean, what do they represent? What does A represent in this problem? It's the future value. It's the amount that something will cost in the future. What does P represent? In this problem, but what does it mean in general? It's the principal. What does principal mean?
The initial amount.
The initial amount. Either the amount something costs, the amount of the loan, the amount of money you put into in a bank account. It's an initial present amount. We also sometimes call it present value. Okay? The current price right now, or the current value right now. What is this guy E? That is a number, and where do you find it? You use the value in your calculator to do that. Now, I had a few people come up to me after class last time looking for the E in their calculator, and as you do group work today, if you haven't found it yet, we'll find it for you. There's a couple different E's in your calculator. There's lowercase e, which is the one we want here, and there's a capital E. We don't want that capital E. It means something different, okay? So make sure you're using the right button as you're doing this. What is R? It's the interest rate. I'm waiting. As a decimal. Thank you very much. As a decimal. It is very important that we put that in decimal form, right? Yay! Yes. So when we're looking at this particular problem, I don't put the number 5 in for R, right? No, that is not going to be appropriate. You're going to get a funny number. It's going to look like you've got to pay millions of dollars for this car now. That would not be okay, right? Wouldn't be okay with me. All right, how about T? What's T? Time, yes, very specific, in years. And again, not everything is always measured in years. In particular, when you're looking at certain kinds of loans, they don't usually tell you you're taking out a 4-year loan. They'll tell you you're taking out a 48-month loan sometimes too. So you need to be real careful to use the value in years. Okay, everybody good? Remember all those pieces. We had one other formula that had one other letter in it. It was the letter N. It's not in this formula. Do you remember what N represented? It was the number of compoundings per year. It doesn't appear in this formula because this is continuous compounds, but that was also present. All right, so let's put what we have where we need it. What's going to go where? Somebody give me a number to go somewhere.
18.5.
Where will 18.5 go?
A.
A? P?
Or P, yeah. P.
Which one is it?
P.
It's P. Why?
We're finding it.
It's the initial or the current amount. I realize it's not 2010, but it's the initial amount we're talking about, correct? Okay. Now what? Well, E's a number, so I'm going to write E down, right? What's next? 0.05 is R, so that's part of my exponent. Okay, now what? Multiply that number by 10. Why 10? 10 years from 2010 to 2020, right? All right, and this is going to give me the A, which is the amount that I'm predicting for the future. Now, we talked about how to do this last time, but let me remind you of a few things. Here's the first issue. The first and most common mistake is people not multiplying this piece first, and sometimes your calculator is spitting back funny answers because it interprets it incorrectly from what you meant. So, my suggestion is to first go ahead and find out what the E to the 0.05 times 10 is. That is not the E part, but the 0.05 times 10. What is 0.05 times 10? That's 0.5. Okay? Now, whether or not you write that step down, I don't care, but I suggest you do it regardless so that your calculator does not have a mind of its own and decide to do something you didn't intend. Okay? All right, so we found that this is 0.5. Now, again, some of your calculators are going to be fine with you just entering this straight from left to right, and you can do that, and that's fine. Some of your calculators aren't. So you're going to have to deal with this e to the exponent first. Why do I need to deal with the exponent before I deal with the multiplication?
Order of operations.
Order of operations. Okay, order of operations always has exponents happening before multiplication. So we need to make sure we do them in the right order. And some of your calculators will and some of them won't. So we want to be a little bit careful. If you're not sure about which kind of calculator you have, I can answer that question too when we're doing group work. Okay? So we're going to deal with the e to the 0.5. Some of your calculators will let you put in the e button, and then the 0.5 is the exponent. Some of your calculators want you to put the exponent in and then hit the e button. If you do it in a way that your calculator won't let you, it's going to give you an error. So have no fear. It's not going to be like, I can't remember which one it is. Your calculator will flip out and tell you no if you do it wrong. Okay, well. So find out what the e to that power is first and hit enter on your calculator. Okay, is everybody to that point if you have a calculator with you today? Okay, after you do that piece, then I want you to hit the times button and multiply by the 18,500. Okay, are we to that point? Mackenzie, you have a value, I can tell. What did you get?
30,501, and then 34 cents.
Okay, and we're going to put a dollar sign, right? Yep. Because we're working with U.S. currency. All right, so that same cost for an $18,500 car into the future, if we had a 5% interest rate 10 years later, the cost for that same kind of a vehicle, okay, not the same vehicle, would be $30,000 instead. Okay, and keep in mind, salaries are increasing and whatever too. So it's not just the product that goes up in time, right? You've all had parents and whatnot who've told you the price of milk or the price of gas what it was 30 years ago, right? And it sounds really good until you find out they only made $2 an hour. You guys know what I'm talking about, yeah? Okay, so keep that in mind as you're looking at this. But this is how inflation works. Any questions on that one? Okay.